Hi again, and this is Dr. Mahmoud. I will be providing another example on process capability. For this example, we have a fairly manufacturing company uh, prides itself on the quality of its products. The company is engaged in competition for a very important project. A key element is a part that ultimately goes into precision testing equipment. The specification is 8 plus minus 3 millimeters. Management is concerned about the capability of the process to produce that part. The following data showing on the left side were randomly collected during test runs of the process. So we have 5 samples, as you see here in this data. And this is observation, 8 observation in millimeters, in millimeters. So the first thing that we're going to do is to find what would be the average for these data in order to find out the CP or the CPK. And we have the equations here on the screen, on the right side of the screen. Assume the process is statistical control. Assume that the process is in control. Is the process capability of producing the part at 3 sigma level? So, and explain. So we need to find out if the process capable or not. They're saying the process is in control in terms of the control limits. But what we need to do, we need to find if the process is in control or not. And this is again for testing the specification for a specific part. We have 5 observation, 5 samples and 8 observation. So the first thing that we need to do, find the average of these. So we did find the average for each of these samples, one by one, average, and selected the value. And then we did the same thing for all the 5 samples, and then find average of the averages. And then now we could do the ranges as well. And the reason for finding the range, because we need to find the sigma. And the sigma, the standard deviation, can be calculated using this equation. I'm going to copy it here in just a second. All right, here you go. All right, so we're going to use the ranges and the average of the ranges to calculate the standard deviation. So we did find the average of the averages. Now for the range, maximum minus the minimum. And then we take the average for the ranges to find the R bar. And now for the standard deviation, we need to find out, we have 8 observation. So 8 observation, D2 would be 2.87. R average would be 2.64 divided by 2.87. So the standard deviation is 0.93. Also, we could use is using the standard deviation using Excel function, which is the standard deviation for the sample. And that would be finding the standard deviation for these here. And that would give you the standard deviation for these values. All right, so we're going to select all these values, which will give us a value closer to 0.93, and this is maybe the more accurate. So we're going to use this one here. All right, so the upper specification limits here, the upper specification limits is 11, and the lower specification is 5, and this came from the question here, 8 plus minus 3. So if we said 8 plus 3, that would be the upper specification. 8 plus 3, that would be the upper specification. And 8 minus 3 would be the lower specification limit. That would be the lower specification. And again, this is given. It's not that we did not calculate that. All right, so in order to find the CP, you find out the upper specification minus the lower specification divided by 6 sigma. So upper specification, 11 minus 5 divided by 6 times 0.93. So that would give you 1.078. Now for the for the CPK, I'm going to do here upper, and lower, and I will be selecting the minimum between these values. So for the upper would be the upper specification limits minus the average divided by the 3 sigma, 3 times the standard deviation 0.93, close the parentheses. Okay, so that would be 835, and the lower specification limit would be equal to the average minus the lower specification 5 divided by 3 times the standard deviation 0.93. And I'm going to put parentheses here to ensure the priority goes here first for the parentheses. All right, so now we're taking the minimum between these two. Close the parentheses, and that would be 0.83. All right, so let's see, there's something wrong here with this answer. So this is okay, 11 minus the 8.63 divided by, all right, here you go. Here's the problem, is right here, we don't have a parentheses. So we're gonna make sure that we have to conduct this first. And same thing here. We have to have some parentheses in here. All right, so now I think it's good. I'm gonna say yes. All right, perfect. Now we have the same answer. All right, so I would rather to just use the up on a separate cell, use the upper, calculate the upper bound and the lower bound, and select the minimum between both of them, and that would give you the CPK. That would be the CPK. All right, so what would be the result? The CP is more than 1, as you see here, more than 1. So that's good. So it's potentially capable. However, the CPK is less than 1. And what does that mean? That the process is not capable of meeting the customer specifications. However, if we could maybe adjust the variation in the process, that might eventually meet the custom, because this is the CP is just potentially, this is the actual. So actually, we're not able to meet the customer needs. So we need the process to be adjusted. And how we're going to adjust it? As you see, this is the upper bound is less than 1. So it is shifted to the right side. So it is closer to the 11. The values you see here may be closer to the 11 than the lower specification. So we have to, and as you look here, the averages is more than the specification. Is closer to the upper specification, and that's why it's not capable. So we need to readjust the machine and reduce the variation to bring the process shifted to the left and make it centered to be able to meet the customer needs. All right, with that said, I'd like to thank you. And that's it about the process capability. Please let me know if you have any other questions or concerns. See ya.